Hi, and welcome to High School Hacking. In this video, we are going to be building a compressor test stand. Before we continue, we should probably talk about what the point of a compressor is. So, a compressor literally does what it says. It compresses air. Now, why do we want this? The thing is, the higher the pressure we get in the combustion chamber, the more oxygen we have in the combustion chamber. And the more oxygen we have in the combustion chamber, the more oxygen can react with the fuel, and hence the higher the explosion, or the combustion. And the larger the combustion, the more energy we create. So, essentially, higher pressure equals more energy, or a better jet engine. There are two types of compressors. There are axial compressors and radial compressors. The main difference is axial compressors, the air is moving in the direction of the airflow, or parallel to the airflow. While radial compressors, the air is moving perpendicular to the airflow. So axial compressors, the main downside is that you need a lot of stages. Each stage only increases the pressure by a small amount, but they're far more efficient because they don't have to redirect the airflow. Radial compressors, on the other hand, are far more compact. You only need like one stage of a radial compressor to get to the same pressure, but they're far less efficient because you have to redirect the airflow perpendicular and then back into the right direction. You see, in general, axial compressors are used on larger jet engines, like those using commercial airplanes, while radial compressors are used in smaller jet engines, like those found on the typical mini jet engine for model airplanes. You see, I might have lied to you when I said there's two types of compressors, so I'm going to use neither of them. I'm going to use what's called a hybrid compressor, where you use both. You have a single-stage radial compressor and a single-stage axial compressor. And this gives you a bit of the benefits of both. You get the small size of a radial compressor plus the higher efficiency of the axial compressor. So my plan is to create a bunch of different blade designs, test them all and figure out which one's the best one. But to do that, we're going to need a test stand. Cue the video montage. Yeah, so the clamp might not have been tight enough. Let's try that again.
I think I know what the problem is. Essentially, the clamping piece is clamping down on both the compressor and the rod, and if it clamps down on the compressor piece first, then the rod won't be clamped down as strongly. So I counted on the flexibility of the plastic to make up for any measurement inaccuracies, but clearly the distances were wrong. Take 3, here we go.
Now let's see some slow motion shots. Thanks for watching. If you're interested in seeing more, please subscribe.